Before we get started talking about joints, I want to point out the pretty bouquet on my desk over here. I got that today from the Friends of the St. Clair River, who have partnered with SC4 to help maintain our bioswales. If you haven't had a chance to see the bioswales in the main SC4 parking lot, you should take a look. Sometimes people think that we've just let a lot of weeds grow up in the rows between the parking spaces, but in fact, those plants are native plantings that are there on purpose. Our bioswales and rain gardens have a couple really important features. They're places for displaying native plants. They provide habitat for insects, birds, and small animals. And very importantly, they help to clean the water runoff from our parking lots to prevent polluting our rivers, the St. Clair River and the Black River. We're really close to both rivers. We have a lot of exposed pavement for parking, and whenever it rains, all of the pollutants, all of the vehicle fluids and everything else from that parking lot would run straight down into the storm drains and untreated on into our rivers. With the bioswales, the extra water sheeting off our parking lots can go into these planted areas and filter through the plants and the soil to be cleaned up before that water could seep back into the river. Now let's go on and talk about joints or articulations. A joint or an articulation is a place where two bones come together. There are a couple different ways to classify articulations based on what holds the bones together or how they're able to move. Now I want to focus on the structural classification of joints. So we'll talk about 4 different types of joints based on what's holding the bones together. Let's start with bony joints. Bony joints might not be considered joints at all because a bony joint is a place where 2 separate bones fuse together into one. So we had ossification of any tissue in between them, so we fused 2 bones into one. A few examples of these would include where 2 halves of the maxilla join together into one maxilla, where the 3 parts of the os coxa fuse together. That would be the ilium, the ischium, and the pubis. The bones that form the sacrum begin as separate bones that then fuse together, so they would be held by bony joints. And the coccyx is another example. These joints have no mobility. Because it's bone that's fused together with bone, they don't move at all. A second type of joint is a fibrous joint. In fibrous joints, 2 bones are held together by collagen fibers. These are usually held very closely or very tightly together, which gives them very limited movement, if any at all. Some examples of fibrous joints include the sutures of the skull. We saw the sutures of the skull when we were doing the bone unit, and you could see how 2 different bones of the skull were held very tightly together in this suture. Those are actually connected by bands of collagen fibers. Another example of a fibrous joint is the syndesmosis, or sheet of connective tissue, that holds the ulna and the radius together. If you were to look at the ulna and radius, you see a sheet made of all these collagen fibers holding those 2 bones very tightly together. Another type of fibrous joint is a gomphosis. This is what holds your teeth into your jaw. And again, we can see bands of collagen are responsible for actually holding those together. In cartilaginous joints, bones are held together by cartilage. Cartilage has a little bit more flex, which gives these joints a little bit of movement. We don't have a lot or extensive movement, but you can get a little bit of bending between the 2 bones held together by cartilaginous joints. Examples of cartilaginous joints include the pubic symphysis, where the 2 halves of the pubic bone are held together by a tough pad of fibrocartilage that's important for absorbing shock between those bones. We also see cartilaginous joints between the ribs and the sternum and between the vertebrae. Remember the intervertebral disc between the vertebrae. That's made largely of fibrocartilage, and again is going to help absorb shock between those bones and also allow a little bit of flexibility. We have as much flexibility in our back as we do because we have many because we have joints between many vertebrae. If we only had one joint, because it's a cartilaginous joint, we wouldn't have a lot of movement. But because we have many vertebrae, we get a little bit of movement between each of them, and that gives us a lot of movement overall. Synovial joints are the type of joints that have the most movement. In a synovial joint, the two bones are held together by a joint capsule, and within that joint capsule is a slippery fluid called synovial fluid that allows the two bones to move against each other easily. So synovial joints are often called freely moving joints because they do have quite a bit of movement. Examples of synovial joints include the shoulder, the elbow, wrists, fingers, hip, knee, ankles, toes, the joint between your temporal bone and the mandible, and others. We can classify synovial joints based on the type of movement they allow. The synovial joint that allows the most movement is a ball and socket joint. In a ball and socket joint, one bone has a round head that then fits into a cup-like socket in another bone. For example, the head of the femur fitting into the acetabulum of the os coxa, or the head of the humerus fitting into the glenoid cavity of the scapula. These are ball and socket joints. These joints allow a lot of movement. They allow movement in 3 different planes or 3 different directions. These joints allow movement forward and back, they allow movement in and out, and they allow rotation. So that's our movement in 3 different planes that we get only from our ball and socket joints. Hinge joints allow movement in only one plane. For example, the elbow will only move in one direction. I can move forward and back in this plane, but I can't move my elbow side to side, and I can't rotate at the elbow. I can't rotate my ulna relative to my humerus. The knee is another example of a hinge joint, as are the joints between the phalanges and the fingers. Not the joint between the phalanges and the metacarpals, but the joints between each of the phalanges. They move only in one direction, so I can bend the end of my finger this way, but I can't bend it to side, and I can't rotate my finger. Pivot joints also allow movement only in one plane, but they allow rotational movement. So where we have bones that can rotate around each other, we have pivot joints. For example, there's a pivot joint between the atlas and the axis that allows you to rotate your head. That joint doesn't go side to side, and that joint doesn't go front to back. It only rotates because it's a pivot joint. There's also a pivot joint between the radius and the ulna. The radius can rotate around the ulna in a pivot joint. The 3 other types of synovial joints, the condyloid, the saddle, and the gliding joints, all allow movement in 2 planes. So we can have movement sort of front to back and side to side, but not rotation. I tend to lump all 3 of these together because although they have different shapes to the surfaces, which does affect exactly how they move, they all allow movement in 2 planes, and so I lump them together. Examples include the bones of the wrist, which can allow your hand to move side to side and back and forth, but not rotate. If you hold your radius and ulna still, you can't rotate your wrist. That rotation is actually coming from the rotation of the pivot joint between the radius and the ulna. We also see this sort of movement between the fingers and the hand, where we can move a finger forward and back and side to side, but we can't rotate it. Or the thumb, where again, we've got forward and back and side to side, but we can't rotate.